So far, we've covered introduction to database, relational databases, and we also talked a little bit about the ER modeling, data modeling. So we said that the first step when you want to build your database is to define your requirements first, right? Collect the requirements, define your business objectives and the requirements, the functionalities and everything. And then based on that, the second stage was to create the data model. Here we use the entity relationship diagrams for that. And for that, we also explained several concepts, like, for example, the entities. We explained the relationships, cardinalities, attributes, and so on. So, what was an entity? Anyone? Can you give me an example of an entity? Yeah?
Like the type of thing you want to store, like a person, of course.
Yeah, anything that we would like our database to keep track of, right? So we want to like have information about students, then we will have an entity for students, which later will be a table for students. And then that student entity has always some attributes, right? And what are the attributes? Yeah. Properties or characteristics of the entities. Like for a student, it could be the student number, the name of the student, and so on. We also talked about the different types of entities and attributes. So, for example, we mentioned that whenever we have a relationship like many-to-many between two entities, it's better to convert, to break that into two-to-many relationships, into two one-to-many relationships. And so what did we call that? When you have a many-to-many relationship, then you are using an entity in between so that you can get rid of that many-to-many relationship. What was the associative entity or composite entity, right? So a composite entity or associative entity is whenever you have a many-to-many relationship. Like, for example, you have students and courses, right? So you know each student can take one or many courses. Each course can be taken by many students. So this is a many-to-many relationship, right? Whenever you have that, in order to get rid of it, you are using an associative entity, like, for example, enrollment. And you are showing that with a diamond inside the rectangle. In this way, you are breaking that many-to-many relationship into two one-to-many. How? How does it do it? Like, how using an associative entity like enrollment can help you get rid of the many-to-many relationship? So imagine you have this student entity here, and then you have a course here. So we said that each course can, like each student can take many courses. Each course can be taken by many students. And now we are putting this enrollment associative entity in between. So what does the entity, like this associative entity, keep? Like what kind of data we are going to keep in this table?
So use the IDs from the two entities as the primary.
Yeah, so at least like the minimum attributes that this table should have are the primary keys of the two entities that is connecting to. So I forgot to buy the marker. Hope I find one here. There are a lot of stealing, I think, in this university. Like every time I come here, either the HDMI cable is lost or there is no marker. So anyways, I try to visualize So we were talking about the many-to-many relationships. And we said that we are going to use the associative entities, like, for example, enrollment. So enrollment is going to be the link or the bridge between the course and the student, right? And so the minimum attributes that this bridge entity or composite entity should have is the primary keys of the both entities that it's connecting to, because we are going to later query data from both tables, so we need to connect them. Therefore, there is enrollment entity here between the course and the student. Now, what is the relationship between the student and enrollment then? Is it one-to-one? Is it one-to-many? Or is it many-to-many? Anyone has a marker by any chance here? So I can better explain. Hi. So we have, let's say, a student here. And we have a course here. And we said the relationship between these two is many-to-many, and we are going to show, use this associative entity like enrollment here. What are some of the attributes of the student? So we have the student number, right? Which is the primary key. And whenever you see the underline is the primary key, which is the unique identifier for your entity and later your tables. And then we have a student names, like let's say, for example, full name, which can be first name, last name, and so on. And here, so we said each student can take many courses, and each course can be taken by many students. But when we use the enrollment, each enrollment is having these student IDs and course IDs, right? These will be foreign keys here. Why? Because they were primary keys in other tables or other entities. So course ID is primary key here. A student ID is primary key here. So when this happens, you have foreign keys here, right? And we also briefly refer to the composite primary key when you don't have a single attribute or a single column in your table uniquely identifying rows for you. So in that case, we need maybe 2 or more columns identifying a primary key. So that is a composite primary key. So for example, here, student ID and course ID together can actually uniquely define instances for you. And so we said that we are going to break this relationship, which was many-to-many, into 2 relationships which are one-to-many. And I'm going to show you how. So in case of many-to-many, we explained. So here we have to say what is the relationship between a student and enrollment. So each student can be in how many enrollments and how many students can be enrolled in one enrollment. So you have to say both sides. So what is the relationship between these two now? So if you see one enrollment later in your table, it will be something like this. So you have this student ID here, for example, 1, 2, 3, 4, 5, and you have course ID, for example, EECS 3421, right? So this is the course ID, and this is the enrollment table. And we may have some other features in this table too. And then then we may have, for example, this student ID, the same ID with different course, right? So we may have this with, for example, I'm just putting the numbers to, so this is 3421, this is 3401, this is 4412. So up to here, a student ID is the same, right? So this enrollment table so far is showing different courses that one student is taking, right? So for example, this is, I don't know, Mona taking a database course, taking the AI course, taking the data mining course. And then we have, so SID, student ID cannot be primary key in enrollment table, right? It is obvious because it is not uniquely identifying. It is not a unique identifier. So now let's say another student is taking the same courses. Like, for example, so in this enrollment table, as you can see, neither a student ID nor the course ID cannot uniquely identify your table. They cannot be a unique identifier for your table, right? Because we have several students, several student IDs which are the same. We also have several course IDs which are the same, but together they can form a primary key because we don't have any combination of a student ID and a course ID that is repeated, right? And that makes sense because if you show that Mona took this course, so we don't need to repeat that information anymore. And so that is a composite entity. Now, this is how it actually breaks the many-to-many relationship for you. So this was your student table. So here you have a student ID, name, etc. So for this student 1, 2, 3, 4, 5, it is Mona, right? And then you had the courses. So here you have a course table, right, with the course ID and the course name and so on. So the course ID, for example, was 3421, 3401, 12, and so on. And this is, for example, AI, this is data mining, this is database, and so on. So without this table, it was like you faced several violations if you wanted to just keep it without the enrollment table. Why? Because here, if you want to show, for example, if a student is taking several courses, right? So if you put the course here, right? How do you want to design it with only like these two tables without the enrollment? Can you think about it? Like, let's say we don't have the enrollment table. So here we have different students, like this could be Alex, and then, for example, 5, 3, 4, 1, and other students like Jack, I think. And then Mona is taking several courses, right? So then I have to repeat Mona several times, and then the student ID will not be unique anymore. And on the other hand, if like in the course table, we will have the same problem if it's taken by many students, right? Then again, we have to repeat. But here, when you are using this intermediary table, which is an associative entity, then now you're breaking it into one-to-many relationship. How? Because each student now, the relationship between a student and enrollment is that each student is, you can see for each enrollment that is associated with only one student and courses, right? You cannot see two like enrollment repeated, like the same enrollment repeated twice. And so the same is, for example, in the context of the e-commerce, when you place orders, and orders have like order lines, including, for example, items that you bought, maybe several items, several quantities of the same item, for example. Then in your order line, each line, if you have the order line table, each line of the table, each row in your table is referring to like just one item, and then you're identifying the quantities of that item. So that is also another example of associative entity in the context of e-commerce, to just get rid of the many-to-many relationship. And here, the relationship between course and enrollment is also one-to-many, because like for each enrollment can be like related to only one course, right? Not more. But one course can appear in several enrollments. And so let's back to the example here. So for example, here you can see a diagram for the ER model, the relationship between product and customer. So for example, each customer can place many products, and each product can be placed by many customers. This is again another example of many-to-many relationship. And then you have like this sale transaction in between. And we have, again, that is what I was mentioning about the order line. The relationship between product and sale transaction is also many-to-many. Why? Why is this a many-to-many relationship between product and sale transaction? Yeah?
Because each product can be bought multiple times.
Okay.
And also each sale can include multiple products.
Yeah, so each product can appear in multiple transactions, right? So for example, milk, you go to grocery and you buy milk. The milk can be appeared in multiple transactions, right? With different people, for example, or several times by like the same person. And in each transaction also we can have multiple products. So this is a many-to-many relationship. In each transaction we can have milk, we can have fruits, and so on. So there are multiple products. Now, how to get rid of this? We're using an associative entity. So we can use like the order line or transaction line, where to break down the M-to-N relationship between product and transactions into one-to-many relationships. And I'm going to show you later today. And so we already explained this. We also talked about different types of attributes, like the key attribute, which is the unique identifier, single valued or multi-valued, when an attribute can have only single or like multiple values. For example, a phone number we said could be multi-valued. And then we had also composite attribute, which I said please do not confuse it with composite entity or composite primary key. They all have the word composite, but they are different things. In case of composite attribute, it means that it has different components, like the address, which consists of the a street number, a zip code, and so on. Or, for example, full name, which consists of first name, last name. And then finally, derived attribute, which was just derived from the values of other attributes, like the age. You get the age from, for example, date of birth and today's date, or for example, total sale, something like that. So these are just reviews. And We also explained different types of relationships and cardinalities. We said that the type of relationship, what you see here in this page, is like to say more accurately, this is a type of relationship that is one-to-one, one-to-many, many-to-many. But the cardinality is just referring to how many instances of them are relating to each other. Like, for example, if you say a professor is teaching, for example, can teach no courses or can teach up to 5 courses, then that is the cardinality, that specific number. And then here there are just the symbols that you're using, some examples for different relationships. Associative entity we explained a lot. And the course enrollment, which I just explained. So is this ERD clear for you? Yeah.
I just have 2 questions.
Yeah.
So for an associative entity, are we representing it in a separate database table?
Yeah.
Okay. And then are many-to-many tables frowned upon, or are we just not supposed to use them?
It's recommended, like for this course, when you see them, try to break them down into one-to-many. So later when we talk about the functional dependencies, normalization, then you better understand the type of like issues. Otherwise, like later, you have to like do some normalization.
Okay, makes sense.
Yeah.
Thank you.
And so for the purpose of like for your assignment, for example, or for your project, because I would like to know that you understood the concept of associative entity, so I recommend you to use associative entity when there is a many-to-many relationship. And yeah, do you have a question?
So Monday I had a question about the course and the prerequisites.
I'm actually going to back to that today. Yeah, I'm going to further explain on the course prerequisite and different things that we can.
I had an idea Monday I couldn't have a chance to ask, but would it be so if we have a like relationship called prerequisite and from course to itself,
yeah,
it's one-to-many. Is it a way to solve this properly?
Yeah, one way is called a referential relationship or unary relationship, which I'm going to explain today. That is one way, or use it as an associative entity. That is also another way. So there are different ways to show that. Yeah. No worries. But is that clear why it is not attribute now, right? Okay. And here, this is just some, I put some slides for different ER notations that you may see outside. Like you may see, for example, the chain notation we are using, the cross-foot notation, or for example, UML class diagram, and things like that. So here, again, shows that just the cross-foot notation. Okay, the relationship, which we mentioned, is the link or how we connect two entities together, the association between two entities. The degree of the relationship is how many entities are involved. For example, sometimes entities have relationship with themselves, which I'm going to explain. That is, for example, one type, and the degree is 1. If it's, for example, with 2, then the degree is 2. And the cardinality is just the number of instances of one entity, like, for example, a professor, that can be associated with each instance of another entity, like a course. Okay, a professor, each professor can teach, for example, up to 5 courses. So these are the degree of relationships that I wanted to talk about, like the binary relationship, unary, and ternary. So the binary is the most common one that you see when we have like relationship between two entities. So this is the most common one. And then we have the unary one, which is when an entity has relationship with itself. And can you give an example of that? When a relationship is just between one entity with itself. So you can think of an entity where there are some, for example, in the context of organizations when there are hierarchies for employees, or the course prerequisite example that your friend mentioned before. So do you want to, anyone want to give an example? Okay, yeah.
So in the employee, so you can make a manager and supervisor.
Yeah, exactly. So if you have an employee table, then in an organization, employee can be, for example, a manager, right? It can be like subordinates. So if you want to like show the relationship, that is also one way. You can say, okay, so each employee can like have only one manager, one and only one manager, and each manager can like supervise one or more employees, and so this is like a one-to-many relationship. And the relationship, all the relationship is between the employees, because manager is also an employee, right? Or for example, like it might be even more sensible if I call it this way. If in an organization there are like even like different supervisors supervising different teams, and then we have like subordinates, then that is a good way to show the relationship between instances of the same entity, right? Because they are all employees, some of them are supervisors, some of them are subordinates, and they are managed. For example, subordinates are supervised or managed by the employees, and then you're just showing the relationship, like for example, employee with itself, right? So for example, managed by something like that. And a ternary relationship is when three entities are associated. So this is actually a relationship that involves more than two entities. Like for example, in the real estate context, the relationship that exists between buyer, seller, and the property. So each buyer can sell different properties to different buyers, and each buyer can buy different properties from different sellers, right? Where each property can also be bought by different sellers or sold to different buyers. And we talked about participation, like when I said, for example, let's say student and supervisor, and okay, we say each student is, the relationship could be supervised by, and the relationship is one-to-many, right? Where each student can be supervised, we assume only by one supervisor, and each supervisor can supervise like more than one student. So in this case, I showed you, for example, these signs. So whenever you have this is showing one. Whenever you have this is showing many. Now this relationship could be, in terms of participation, could be mandatory or optional. When it is mandatory, it means that there should be at least one instance. Like for example, each student should have at least one supervisor. If we assume that students can have no supervisors, then it is optional. So let's say our assumption is that each student should have at least like one supervisor, or should have one and only one supervisor. If we say each student should have one and only one supervisor, so okay, each student should have one supervisor. Is it mandatory to have any supervisor at all? Yes, so it is mandatory. And this is the sign. But if it is optional, so we say a student either has no supervisor or just one supervisor, okay? So it has one supervisor, but it can also have no supervisor. Then it is optional, which is shown by this oval. And the same is true for the many relationship. Like, for example, you can say a customer may purchase many products, okay? But a customer may also purchase no product, right? So it is either 0 or many. Because customer can purchase like no product, then it is optional. But if we assume that, and this is just an assumption, if we assume that, for example, a customer should buy like many, and then it is mandatory. So this is the sign for optionals or mandatory that we use, and we call them relational participation. So here you see, for example, a course must be taught by one and only one professor, and the professor may teach no course or more up to. So from this side it's optional, but from the other side is mandatory. Can someone explain this? How do we explain the relational participation here?
A woman can bear 0 or many children, but every children has to have one and only one mom.
Yeah. So if a children is born, so it should have been like someone bearing that child, right? So this is a mandatory relationship, and like none of us like came here from like two mothers, right? Like it's just one woman. So it is one and only one. So each child is coming from only one and one woman. While each woman can have many child, but is it mandatory? Like, should have all women have child? No, we have some women who has no child. And so this is optional and can be many. So is this clear? Okay. Is it getting boring? How many of you think it's getting boring? How many are you sleepy right now? Okay. How many? So do you want like 2 minutes break if you feel boring? So how many of you need a break? Like I was always, my hands was up if someone offered me a break. Okay, so we continue. We have also, sometimes we have multiple relationships. Okay, so for example, if you see this slide, it's showing an employee and department. So you see different types of relationship here. I'll like to you. A relationship between like one entity with itself, which is the employee, right? So the employee has this relationship with itself, which I already explained, because we have some employees who are supervising other employees, right? So each employee can supervise 0 or many other employees, right? And that is why you see like this sign here. So this is the optional part and this is the many part. And each employee can be supervised by one and only one supervisor. So we cannot have an employee with no supervisor. We cannot have an employee who has no supervisor or more than one. Or another way to design it is with different assumption. So what about a CEO? So we may have CEO who is an employee, doesn't have a supervisor, right? What would be the difference in that case if you assume that you have also a CEO who is having no supervisor? Anyone else? So what will, like in terms of like this relationship, what will be changed if we assume that an employee can have no supervisor? Yeah, this is just would be an optional. So instead of like this line here, we will have an oval that shows it is optional. And then the relationship between employee and department, this is also another type of relationship that you haven't seen before. So far we always had like one relationship between entities. but sometimes two entities may have more than like one relationship with each other. Like for example, department and employee. One relationship could be that we say, okay, each department can have at least one or more employees, and each employee can work in only one and one department, right? Why is this like mandatory here? So always when I ask this, you have to ask yourself, can you have no or zero instance of that? For example, can we have, for example, departments with no employees working in them? Doesn't make sense, right? It's not efficient. So it is mandatory. And then from the other side, each employee should work in one department. So if an employee is not working in any department, it's not an employee anymore, right? It doesn't make sense. So it should work somewhere. And also, okay, sometimes I actually have some colleagues here working like in different campuses. So if that is an assumption, so this will be like many instead of one. So all of this depends on your assumptions. For your assignment, for your project, be careful that your ER model is compatible with what you have defined in your business rules and assumptions. And the other relationship between employee and department, because employees could also be managers, then this is another type of relationship that, for example, an employee who is, for example, supervisor, manager, can manage a department, and a department can be managed by an employee or a manager. Another type of relationship, supertype, subtype. So this is also a helpful one. So for example, let's say you have an employee, and then we have different types of employees, right? We can have a full-time employee. We can have, for example, contract employees and so on. So can they, do they have like the same attributes? Full-time employees, contract employees, do they share the same attributes? Yeah.
They share some, but not necessarily all.
Yeah, so some attributes are the same, like all employees, regardless of whether they are contract or they are full-time or whatever type they are, they have some employee ID, they have a name and this type of information. But then there are some also, they may have attributes of their own. For instance, if it's hourly employee, you may have hourly rate. If you have contract, for example, consultant, you may have contract number. So they also have some attributes of their own. And this is how we show them. Like, for example, here's an employee, and then could be hourly, salaried, or other types. Do you have any question? No question? What is the difference then, if you understood this correctly, what is the difference with unary relationship that I explained before when I mentioned that employee can be an employee or a manager, can be supervisor or subordinate? So could we design an ER model with employee and these like manager like or subordinate types as subtype, supertype? Can we? Yep. And so what was the difference with that, like the relationship with itself?
So I wasn't here for some part of it, but for subtype, for like a manager or for any other role, they would just have more attributes, including all the other attributes that an employee would have.
Mm-hmm. Yeah, we could actually have like employees as subtype, supertype with like managers and so on. The only difference is that at the time we were talking about the referential relationships, and so it involved only one entity at the time, right? And we were talking about and it didn't have a specific attributes of itself, right? So that was a relationship. But in case of subtype, supertype, you have a relationship like for your subtypes and supertypes, which are different from each other. And here is just the disjoint constraint. If, for example, you have an employee that is full-time and part-time, this is just a type. Like, for example, they have like no overlap together, or if they have overlap, like, for example, runner and jumper have some overlaps. And the weak entity, which last week I mentioned that I'm going to explain, sometimes you have some entities that they do not have their own primary keys, and often I will also let you know later, often we whenever you have like multi-valued attributes, this is just a hint, you may be able to use a weak entity instead of that. And a weak entity is just an entity that is dependent on another entity for a primary key, because its key doesn't uniquely identify it. It cannot be used as a unique identifier. So for example, we have a course entity, right? Course entity has course code and description. And then we have the course section, because one course, like let's say some of the courses in New York University, because the classes are large, they have different sections. So for example, database have section M and N, or for example, the Python course had section A, B, C, right? So they have different sections, but they are still the same courses. So in that case, if you have a table for the course section or for classes, their key, or if you want to like define a key, is dependent on the course, because the section itself doesn't uniquely identify. But if you use, for example, the course code, which is the primary key of the course, in combination with the section, so if you say, for example, 3421, which is for database code, right? 3421 section A. So A, section B, and C. And then it can uniquely identify the row. So is an entity that is existent dependent, has primary key that is partially or totally derived from the parent entity in a relationship. So I'm going to explain it further. So a weak entity is an entity that doesn't have unique attribute of their own, is represented by a double line. I'm going to provide you an example in the next slide. And each entity should be associated with its owner, and we use a double frame diamond to represent that. So represent it this way. And so in the example that we are using in the next slide, a class is a weak entity because section number is only unique if it is used along with course and course code. So what we saw here, so for example, in the course code, in the example I said, okay, so we can say database and, for example, the course code, or could be the course code and the section number, something that together you can identify. So this is another example. Like, for example, if you say section 3 is not unique because other courses can also have the same sections, right? So, for example, here you see the same course with different sections. But each of these sections can also be for other courses. Like, for example, there could be the another course, or let's say 1015 course. 1015 is has section A, has section B, and so on. So the section number itself is also not unique. So this is an example. So as you see here, so we have a course. So let me Okay, so we have a weak entity class here. So each course can has one or more classes, right? And each class can have one or more courses, right? Because one course can be taught in different classes, or each class can have like different courses. Here, the assumption was that in each class there were only one course, like at maybe at just the same time. Like for example, in this class there is only one course, and so this is a one-to-many relationship. And why class is weak entity here? So just based on what we mentioned that they do not have their own primary keys. Yeah.
Class can't exist if there isn't a course.
Yeah, the class cannot exist if we don't have a course, we don't need a class for that. Like it's better maybe to say like with a section, right? So we say, for example, a database section ABC, right? And if we don't have database or the courses at all, then why should we have a section, right? So because all the sections are coming with the courses. So we say database section AB. We say AI section ABC. Or for example, machine learning section 1, 2, 3. So does it make sense to have a table for section when we have no courses? No. Section alone doesn't make sense. So this is how you show it, and also make sure that the relationship is also reflecting that. So whenever you have a weak entity, you also show your relationship with a double diamond. So what else I haven't explained here? Yeah.
So like this, are weak entities and composite entities just different ways of doing the same thing? Or like is there a difference? Because they're both
Composite entity, like for example, you mean the class is a composite entity?
we can just instead of the class entity, couldn't we just like use make it a composite entity?
So composite entity is an entity which, okay, so I think you mean the composite relationship associative. What do you mean? Because
Like just like we did with the student and course, couldn't we like do the same for say or like
with the student and class, you mean that we use the enrollment?
Yeah.
Okay, the enrollment is associative entity, right? Which connects the class to the student, right? And so if we use class as an associative entity, which would be the two entities that it is connecting to? Or are you going to add a new associative entity between course and class?
can we have can like can associative entity be connected to another associative entity?
No, associative entity is connecting two entities. So in this case, if you're using an associative entity, so let's think about it and see if we can model that. So you want to use an associative entity between which entities?
Between like for example a class between course and enrollment.
So the class would be another associative entity then? But is there a many-to-many relationship between the course and enrollment? No, you can like on paper, you can try like different models and see if that makes sense and convert those like entities to tables like what I did at the beginning of the class to see if, for example, adding an associative entity makes sense. So what I show you in class may not be the only like feasible ER model to show this, right? Sometimes you don't even like use weak entities. Instead, you are using multivalued attributes. Like for example, in this here, the class may just be a bit confusing. Think of it as a section, okay? A course that has like different sections. So you can use it as a multivalued, like use section as a multivalued attribute, which can be like ABC, right? exactly like the phone number. But even if that is the case, it's often recommended to use convert multivalued entities attributes to a weak entity. So I also included that in the slide as just a recommendation. So is a weak entity clear? Yeah. I'm sorry. Associative. We don't have associative attributes. We have associative entity. Yeah.
So we are making them for many to one-to-many, right?
Yeah.
Is that the same or kind of what we do in normalization too?
What we doing?
Does it have the same meaning with doing normalization? When we do.
If you don't do that, then later we do the normalization. Yes.
But they are doing kind of the same thing, the same process that we do.
That is why the data modeling phase is the very important stage, because if you do it properly, it like saves you a lot of time later. Okay, so where was I? So these are just some like reviews and recommendations when you build the ER model to understand your business rules, identify entities, relationships, attributes, and converting ER model to relational table, which I explain next week. And for your business rules, I already mentioned it several times. For your project proposal, for your assignment, there is one question where you have to define your business rules. So try to think about the kind of like entities that you want to have, the kind of attributes for each entities, and the relationship. So in that question, you have to say what entities you have. So for example, I have customer, I have buyer, and then products, etc., etc. And these are the attributes. And then you also have to explain all the relationship between all the attributes. So you say for example, customer can buy many products, each product can buy by many customers. So this is one. And the next one, you go to the other two entities that are linked and then describe the relationship. And you do that for all the entities. And here are just some examples of business rules, like a student can take up to 5 courses each term. Even if you just say many, that's okay. You don't have to put specific number. And each course will be taught by only one teacher. Customer may use like credit card to make online payments. So these are all the assumptions that a person can make.
Question.
Yeah.
So when we say business rule, is that kind of we are making relationship, like explaining about the relationship?
You explain about the entities and their attributes and the relationship between entities and the cardinal and the type of relationship and cardinalities. Yeah. So here is, for example, another example. This is just a suggestion that you can discover also some business rules from just the views that you see on a website or application. Like, for example, here you can see, for example, the what features you have, what type of, for example, entities or attributes or relationship you can extract by just like seeing this report. Like, for example, here you see an order, and the order has, for example, order number. Here you see the customer, right? Customer name, address, etc. So you know that, for example, in your entity for customer, you have several attributes, like, for example, customer name. So these are just some suggestions for you to help you with defining your business rules for your assignment. And then after describing like these entities and their attributes, you go to the relationship. Like, for example, a customer may place many orders, or each order is placed by only one customer. And then here you see about the order line that I explained. Order may contain many order lines, right? But each order line is related to only one product, because each order line is saying, okay, this product was sold in how many quantities, for example. And so these are just the business rules. So do we have a volunteer for working with the ERD Plus? So can someone come here if you like, or not, you can explain to me and I will draw the ERD for just this example. So just the relationship between these, like we have entities like products, customer, salesperson, and order, and we want to build the ERD. Do we have any volunteer to help me with this? No one? You don't have to come to like here if you're shy, so you can just let me know, for example, what is the relationship between customer with order, or like even partially saying some of them. Anyone else? So when I ask you, do you have any questions? Is it clear? Everyone say yes. Is that a real yes? Okay. So it's already here. So who wants to draw the ERD using the ERD plus with this answer? And I'll give you some bonus points. Like even with the bonus point, we don't have any volunteer. Who else? I give you like 5%. 10%. Later, 10% was less than 5%. Why? Okay, so yeah, you actually you can come, yes, or you can explain however you prefer.
I didn't get the rest.
You can explain the relationship that exists here, the business rules here,
Okay.
and we can try to do it on ERD together. Okay. Take the entities and the relationships that we have. So this here is the more complete one. So we have a customer, right, which is can place many orders.
Yes, so product has an associative relationship with orders. So each order can have many products and each product can have many orders.
Mm-hmm.
And orders also have a many-to-one relationship with customers. Each order can be placed by only one customer, and one customer can place many orders.
Yeah.
And also, each order can be prepared by one salesman,
Mm-hmm.
and one salesman can prepare many orders.
Yeah. And what about the relationship between product, order line, and then order with order line? How did it break it into one to many?
Sorry, can you ask that again?
Yeah. So the relationship between product and order was many to many. Then we use associative entity order line. So now, what is the relationship between product and order line?
Okay, I see. So product and order line is the associative entity, and each product can have many order lines,
Mm-hmm.
and each order line is composed of different product numbers and quantities and order numbers. I don't know.
Yeah, if you see the order line, which will be your table later, right? So it has the product number, which was the primary key for the product, and order number. Together, these two are like unique identifier for the order line. So in the order line table, we will have a product number and order number. Now, we may have many same products in the order line, right? In the product table, we can't. Also, in the order table, we only have one order number. But then, how do we manage, for example, when we have, for example, we are buying, we have orders containing like many products, and we like do it appearing in multiple orders, right? So to avoid that, we have this order line table. So here we just have then order ID. We have order ID and product ID and maybe some other things. Just here I want to focus on that. So order ID, let's say, is 1, 2, 3, 4. This is product ABC. And then again, this order can have another product. The same order can have like another product. Now, this product can also appear in other orders, right? Because, for example, I may order this product, another person may also order this product. I may order this product several times on different dates. So this also may be related to different order IDs. So here it was for this order, but we may have it for example, order 5. We may have, again, the same product in another order, and so on. But this combination is unique here, okay? So in each order line contains only one product, each order line, like each instance of the order lines in the order line table. And so each product, this is how it broke it down into one-to-many. Each product can appear in multiple order lines, right? But each order line is related to only one product. And then again, each order can have many order lines, but each of these order lines are related to only one order, okay? And so this is how we manage that. So now let's go to the ERD plus. And practice it together. Yep. So what entities do I have? Yeah, I have like order line, but we probably won't start from there, right? We first see that we have a many-to-many relationship, and then we add that. So first, what are the first entities that come to your mind? Try to do it like while I'm doing in ERD, or if any of you want to come and try it. Do we have any volunteers?
The same thing? Are we recreating the same chart?
You can add, or you can add something if you want. That is just the most simple one. Yeah, that was just to give you an idea of some of the main entities. And I want you to be more comfortable with the ERD plus, like selecting like different types of entities or attributes here. So any volunteer? Yes. Yeah, do you want to do it? Yeah. So you can also add another entity if you think you have to.
Yeah, so first we have product.
Yeah.
Then we
Yes.
have like salesperson.
Yeah, we have salesperson.
Is that the same as like cashier? Because it said prepared. Then we had an order.
Mm-hmm.
Then the other one,
We also have customers who are placing orders. So this is super easy. Like this is almost like the very simplified version of what you are doing for your assignment one for the flower shop, right? Have you checked? How many of you have checked assignment one? Yeah, you can continue that. So how many of you have checked assignment one? How many of you have never checked anything on E-class? Okay. How many of you are hearing me? Okay, good. It's fine, you can delete them, just select and then
undo.
delete. You can also delete, yeah. Mhm.
Then we change this one to associative entity.
Yeah, we have like many-to-many relationship.
So do we like delete this one and just make it an entity?
Yeah, you
right?
can just add an entity here. I don't think it has like associativity,
Yeah.
or maybe if you
No,
select the type of the
does, yeah.
entity, yeah, it has. So do you have any question for the files regarding the files I uploaded for your group project and for your assignment 1? Oh, and for your groups, I already created groups for those of you who gave me your names on eClass. I also asked the IT guys to see how I can randomly create groups for the remaining students. So I'm going to finish that today. I probably extend the deadline for your proposal by maybe a couple of days because it doesn't really take much time for the proposal. It's just a 1 page. And the only reason that I have like this proposal is just to wanted to break down your project into steps so that you don't like be overwhelmed at the end of the semester.
So I think it's done. I just don't know what to name them.
Yeah, and then always remember to add the attributes
Yeah.
to it's okay for now, and also for the relationship always have the names. So thank you so much. Thanks.